Hi students, welcome to the Switching Theory and Logic Design class, Unit 2. So this Unit 2, we are going to discuss minimization techniques. Right. So coming to this minimization techniques, here we have the complete unit. We are divided into two parts. Coming to the first part. The first part, we are going to discuss the concepts of minimization and realization of switching functions using Boolean functions. So the normal Boolean postulates and theorems, the normal Boolean postulates and theorems. By using this Boolean postulates and theorems, we will simplify all the functions. Already we discussed this concept in the first unit end of the part. Again, we will discuss some of the problems how to minimize these minimization of functions by using Boolean theorems and postulates. Next, coming to the second topic, K-map simplification process up to 6 variables. So we will simplify all the given problems by using K-map, that is Karnoff Map Method, which is proposed by Mr. Karnoff in the year of 1953. Next, the third method, tabular method. This tabular method also called MC-Queen-Klasky method. This MC-Queen-Klasky method is the most important method which is used in the present days in the our digital side subjects. Okay, right. Now, coming to the second part of this second unit is combinational logical circuit design. Combinational logic circuit design. The first one is design of half adders and full adders. Design of half adders and full adders. Next, design of half subtractor and full subtractors. So this is the second part. And coming to the third part, applications of full adders. Applications of full adders. So by using the full adder, we have to construct different types of functions like 4-bit adder and subtractor circuit, that is serial adder and parallel adders. Next, Bcd Adder Circuit, that is the adder should perform only BCD addition. Generally, if you are performing, for example, 4 plus 6, that is you will get answer is 10. But the 10 equivalent binary number is 1010. In BCD, we are not representing 10 equivalent value is 1010. The equivalent value is 0001 and 0 equivalent value 0000. So 4 zeros we are representing for 0 representation. So 1 representation is separate and 0 representation is separate. This is the BCD representation. How to do that type of BCD addition, that is also we will see in the coming classes. Next, XS3. So XS3 additions, BCD additions and carry look ahead adder circuit. This is one of the famous and very fastest addition with compared to the normal previous additions. This is very fastest addition. So that is also we will see carry look ahead adder. First we will add all the carries, then we will do the summing operation. And the last one, design of code converters. So XS3 code to BCD code, BCD code to normal binary code. Otherwise, from this codes to another gray code, that is one code to another code, we are converting the different types of operations. Okay, for example, here I have given 1010. This is the binary number. You have to convert this binary number into XS3. We know the basic property how to convert that operation, but this work has to done by the machine. So for that reason, we have to develop a function which will support by the machine. So that type of operations, that is code converting operations, we will see. Code conversion operation we will see by using Karnoff Map Method. So whatever the code conversion operations we are doing, so we have already learned Karnoff Map Method in the first part. Then we will implement this Karnoff map with the help of code converters, and we have to draw the finalized circuit diagram. This is the very most important circuit diagram. The finalized code converter diagram we have to implement. So these are the tasks or motives we have in this second unit. Okay, right. Now we will continue our topic with minimization and realization of switching functions. Right, we will start our topics with minimization and realization of switching functions using Boolean theorems. That is by nothing but as by using Boolean theorems and postulates we will see the simplification process. Right, now we will see here the simplification. Right, here the question is simplify the following Boolean functions which is given in the truth table T1 and T2 to a minimum number of literals, okay. Right, here see the problem here. A, B, C, T1 and T2, right, three input variables A, B, C given, and T1, T2, these two output functions are given. Right, it's a very simple thing. Here we have three input variables, that is f of A, B, C, that is f of A, B, C, three functions given. Right, wait, పాస్ అయిందిగా. Okay, so here the problem is simplify the following Boolean functions T1 and T2 to a minimum number of literals. So in the yesterday class we said that literal is nothing but as A is one literal, A bar is another literal, and B is one literal, B bar is another literal. So here we have three input variables, but here totally we have six different literals. Okay, A bar, B bar, C bar. So totally six literals here we have. Coming to here the truth table A, B, C, these are the input functions, and T1, T2, these are the two output functions. Here T1 is the first output function, here T1 first function and T2 the second function. T1 and T2, two different functions here we have. Right, next coming to here, what is T1? What is T1? What is the function of T1? Here we have to know what is the function of T1. So see here in the given table, in the place of T1, where the output is switched on and where the output is switched off, these are the conditions we have to remember. Right, so you have to consider those those outputs. Right, so coming to here T1, so see here coming to the function of T1, here if you observe the function of T1, here three conditions is on. Right, three conditions is in the on situation, and remaining condition, all the conditions are zeros. Next coming to the T2 condition, so here the first three conditions are off and the remaining conditions are on situations. Okay, right, coming to the T1 situation, here in this T1 situation you have to check. Right, so right, so these three situations, right, these three situations, what is the input for these three situations, that we have to write down. So T1 is equal to, right, so see here what is these three inputs, 0 0 0 0 0 0. So here 0 0 0, that is nothing but as the minterm for this one is m0, the minterm for this one is m0, this is the m0. Next m0 plus, right, the second one is nothing but as 0 0 0 1, right, double 0 1, that is m1. Next m2. So this is the given function, these are the given functions m1, m2, m3, these three functions. Next coming to that second function T2, coming to the T2, here we have, these are the, right, so here we have, these are the functions, these are the output functions. So for T2 here in this these ones are representing T2 function, these zeros are representing not T2 function. So here whenever the output is equal to 1, then only you have to consider the functions. Here T2 function when it is on these situations, coming to this situation, what are these inputs, what are this input, 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. 1. So these are the input combinations. Coming to equivalent decimal value, and what about this minterms values? Coming to the minterms representation. So here the first one condition is representing 0, 1, 1. 0, 1, 1 is nothing but as 3. So the minterm value is equal to here 3. So write down the same function here. That is the first one is M3. The next one M4. Next M5. Next M6. Next M7. Next M7. So these are the input given function. These are the given input functions, right? So these are M3 is nothing but as 0, 1, 1. That is A bar BC. M4 is nothing but as here what we have mentioned, that is 1, 0, 1, 0 we have mentioned, that is A B bar C bar. This is the M4 representation. Those I have represented with M terms. So this we can write in this way. This we can write in this way. That is sigma of small m of 0, 1, 2. 0, 1, 2. Next this one sigma small m of 3, 4, 5, 6, 7. So these are the given input functions. These are the given input functions, right? Let us come to here. We have to write down the sum of minterms. We have written the minterms, sum of minterms we have represented in this way. Coming to here, this is we can write sigma of 0, 1, 2. So here I am saying the maximum possible combinations of writing the given function T1, T2 functions I have written in this way. Okay, so T1, T2, this is the functions. So here the question is you have to simplify. If you want to simplify the given function, here what you have to do, first take the T1 function, write down the T1 function. Here the T1 function you have to write down with minterms the M0 0, 0, 0. That is with the representation of A bar ABC you have to write down. So M1 is nothing but as 3 zeros. That is we have to write down A bar B bar C bar, A bar B bar C bar. These are the 3 input functions here. These are the 3 inputs and their function A bar B bar C. And second output, that is nothing but as M1. Here we have written M1, that we have, that is we represented here, right? So M1, that M1 I am writing here like this. That is A bar B bar C. So this is the M1. Next M2, that is A bar B C bar, right? Now we have to simplify this function. Now we have to simplify this function. So from this two, is there any chance to take common? So here A bar B bar C, this one, right? So in this we can take the common of A bar B bar and the remaining value C bar plus C. Next this is A bar B C bar. So you can cancel this term. So finally you got, that is A bar B bar plus A bar B C bar. So this is the functions. Now coming to here, is there any chance to take the common? So this is we cancel here C plus C bar. Why? Because C plus C bar is equal to 1, and that C here the C plus C bar is equal to 1, and that 1 into anything, finally we got anything value, that is 1 we neglected. So 1 into A bar B bar, that is equal to A bar B bar, right? From this 2, is there any chance to take common? We can take the common from this 2 is A bar. We take A bar and the remaining value B bar plus B C bar. B bar plus B C bar. Now from this 2 we can take common. We cannot take any common from this 2, but this is seems to be like as x plus yz. That is seems to be like as distributive property. That is seems to be like as a distributive property, right? The distributive property we can write like this: A bar B plus B bar into B bar plus C bar. So this is the function. From this function you can cancel this one, B plus B bar we can cancel, and the final value here is A bar of B bar plus C bar, that is equal to A bar B bar plus A bar C bar. So this is the finalized function for t1. So this is the finalized function for t1, right? Okay, coming to the next problem. Simplify the following Boolean function of t to a minimum number of literals. So here the function, see here in this table ABC from 00 to 11 all maximum possible combinations are available, and t is equal to all combinations given. Okay, t is equal to all combinations given. So it's very simple problem. Actually the output of this answer is the output of this problem is equal to 1. The answer is finally t is equal to 1, but here we have to do that practically. So coming to here, that is t is equal to, here see here all the possible combinations are available. So m0, m1, m2, m3, that is equal to sigma small m of 0, 1, 2, 3, 4, 5, 6, 7, that is equal to 0, that is a bar, b bar, c bar, a bar, b bar, c bar, plus a bar, b bar, c, plus a bar, b, c bar, plus a bar, b, c, plus a, b, c bar. Yes, so a, b bar, c, that is equal to 1, 0, 1. Next 1, 110, that is a, b, c bar. Next last one a, b, c. So m0, m1, m2, m3, m4, m5, m6, m7, m0, m1, m2, m3, m4. So we missed m4. Right. So these are the functions. These are the functions. These functions we have to simplify. Okay, it's very simple thing. Right. From this 2, you can take common a bar, b bar. The remaining value is c plus c bar. Okay, plus this goes to cancel. Next, from this 2, you can take common a bar, b. That is c plus c bar. You can cancel this one. Plus next, from this 2, you can take common a, b bar. The remaining value is c plus c bar. This goes cancelled here. Right, this you can cancel. From this 2, you can take a, b, that is final value c plus c bar. So you can cancel these values. So finally is not equal to, right, right. So this continuation only. So for that reason right, now it is equal to, right. So the final values a bar, b bar, plus a bar, b, plus a, b bar, plus AB. These are the remaining values, right? From this 2, you can take common a bar and remaining value b plus b bar, and from this one you can take common a. The remaining value is b bar plus b, right? Next, from this one cancelled, this one cancelled, and final values are a bar plus a bar, a plus a is equal to 1. So this is the finalized answer, that is equal to t. So the finalized function t we have defined like this. Okay, so sigma small m of all functions we have written. From this all functions we have taken the common first a bar, b bar, and c plus c bar is there. C plus c bar value goes to 1 into anything. So 1 goes cancelled. Next, coming to that, a bar, b we have taken from this 2. From this 2 we have taken a bar, b. So c plus c bar goes cancelled. Final value a bar, b. Next, from this 2 we have taken a, b bar, and the final value a, b bar. C plus c bar goes cancelled. From this 2 we have taken a, b value, c plus c bar, that is goes to 1. Next, the finalized value here you got after cancelling c plus c bars. Next, if from this 2 we have taken a bar and b plus b bar is there. B plus b bar we cancelled, and from this 2 we have taken a, b plus b bar is there. We have cancelled that one, and finally a plus a bar, that is equal to 1. So the final output of this function is equal to 1. So this is the finalized answer. Okay, right. Okay, students. Coming to next problem, simplify the following Boolean expression using three variable maps, that is equal to f of xyz is equal to 0, 2, 4, 5. Okay, from the digital design Morris Minnow textbook, I have taken this problem. This 3.1, in this 3.1 we have four problems, A, B, C, D. Almost all seems to be f of xyz 0 is equal to 0 of 2, 4, 5. Okay, this functions already we have solved with two problems. You do this one as a homework. I am not doing this problem here, so you have to do this one as a homework. Next, I am taking one more function here, that is one more problem. So see this problem, simplify the expression f of a, b, c, d is equal to 3, 7, 11, 13, 14, 15. So see here, up to now we have taken 3 input variables only, but in this problem we are taking 4 variables. In this problem we are taking 4 variables. Okay, so a, b, c, d 4 variables are there, and directly sigma small m values given here, that is 3, 7, 11, 13, 14, 15. Okay, so in this problem he forgot to give sigma value. Okay, no problem if sigma is also not there, but here we have the minterms, sigma small m of 3, 7, 11, 13, 14, 15. These are the minterms. You have to remember this one. Actually here it is not mentioned the sigma, but we have to represent the sigma value. So this is the sigma must and should, you have to represent sigma function compulsory, otherwise it is not valid. This is the sigma is there. You have to remember sigma of 3, 7, 11, 13, 14, 15. Right? For minterms they are mentioned like this. If they want to mention the max terms, then they have to represent with pi of 3, 7, 11, 13, 14, 15. Like that we have to mention that sigma values. Okay, sorry, pi values, max terms. If they represented sigma, these are the minterms. If they represented here pi, then that is called minterms. That is also we will do one problem. That problem also we will do in the coming models. Here coming to this problem, see here each function we have to write with 4 input variables. M3 is there. See here the first term is M3. M3 is nothing but as minterm 3. Generally minterm 3 for 4 variables we are representing M3, we are representing 0, 0, 1, 1. Next M7 we are representing 0, 1, 1. M7 over. Next M11, what is the equivalent minterm value for this one? You have to recollect the values, the binary equivalent value. What is 11 equivalent? Right? 1, 0, 1, 1, 8, 4, 2, 1, 8 plus 2 plus 1, 1, 0, 1, 1, 1, 0, 1, 1. That is the 11 equivalent number. Right? M11 over. Next, after M11, M13. This is 1, 1, 0, 1. 8 plus 4 plus 1. 8 plus 4 plus 1 is equal to 13. Next, M14. That is equal to, M14 value is equal to 110. 8 plus 4 plus 2. Here one we are noting 8 plus 4 plus 2. 8 plus 4, 12. 12 plus 2, 14. M15 is equal to 1, 1, 1, 1. So these are the equivalent binary values. Now we have to write down with A, B, C, D input variables. So here, see here M3, you can write this one A bar, B bar, C, D, plus next M7, that is A bar, B, C, D. Next M11, A, B bar, C, D. Next the function 11 over. Next 13 is the next function. So 13 is we have written 1101 A, B, C bar, D. Next coming to the M14 is 1110, that is A, B, C, D bar. Next M15, that is A, B, C, D. A, B, C, D function. So these are the given function. Now we have to do the simplification. So the question is simplify the expression. So for simplifying this expression, right, so again you have to take common, that is a distributive property. Those properties we have to observe. So first see here in this 2, is there any chance to take common? Right, A bar C D is there. So from this 2 we are taking a bar cd. A bar cd is there, that is we have taken common the remaining value b plus b bar. We know that b plus b bar we can take cancel. B plus b bar is equal to 1 into anything. A bar cd is there, plus next from this 2 is there any chance to take common? Right, we will see next. ACD, it's not there, right? Okay, from this 2 is there any chance to take common? AB, right, is not there, right? From this 2 we will take common, that is equal to ABC. ABC we will take common here. D plus D bar is there, this goes to cancel. From this 2 we will take common AD, the remaining values B bar C plus BC bar. Alright, you can take common, otherwise you can leave as it is. We have another functions. With the help of another functions also we will do, right? No problem. So see here, a bar cd, the remaining value is a bar cd plus here, right, a d. This is nothing but as b exclusive c. It seems to be like as a b exclusive c. Keep like that only. Otherwise you keep like that only, a b bar d, like that. A b bar cd plus a b c bar d. Those terms I have written like that only. I will see any modification, any simplification is there directly. We will see here the remaining value is a b c. Remaining values a b c. Right. From this, is there any chance to take common? So see here, from this 2 we can take common AB, right? So see here, A bar CD is there. So from this 2 also we can take CD common. CD I have taken common, A bar plus A B bar. Next, from this 2 we can take common A B. AB we can take common, right? Next, the remaining value C plus C bar D. Okay, right. So see here, this function we can write with using distributive property. With using distributive property, we can write by using distributive property we can write this function for x plus yz is equal to x plus yz is equal to x plus y into x plus z. That is a plus a bar into next b bar plus a bar. That is equal to the final value c d into this becomes a bar plus b bar. Okay, how I written this function is, so see here, that is a bar plus a b bar, that is we can write x plus yz formula, that is a bar plus a bar plus b bar. A plus a bar goes to cancel, a plus a bar goes to cancel. Okay, right? So a plus a bar goes to cancel, the remaining value a bar plus b bar, that is I have written here. Like that only I am writing here x plus yz formula, I am applying same here, and the final value is equal to c plus g, that is equal to here a bar cd plus here b bar cd plus next from this a b c plus a b d. So this is the function. So this is the function I got. Is there any further simplifications from this? Is there any simplification from this? We have to check. Is there any simplifications? A bar cd plus b bar cd. B bar c is not available. CD is available? No, not available. Okay. I think that this is the simplification, final simplification. But even though, is there some chance to simplify that expressions? Oh, from this a, b is there. We cannot take common values here. So see here, from this 3, we can take common c. That is equal to c after taking common a bar d plus b bar c plus, oh sorry, we have taken c only common. Right, b bar only we have taken common. So c common, b bar d is there plus next ab is there. So these are the values we have taken here plus abd. Is there any chance to again, right? So furthermore simplifications also there. See here, from this 2 you have to apply xyz formula. Okay, otherwise from this 2 also you can take the xyz formula, x plus y z into x plus y into x plus z. Okay, here finally, so see here, lot of complications are there, how to simplify and which the terms we have to take common. Here I have taken common in this way, but I'm not giving any solution and I have given the work to you. Now what which type of terms you will take common, that is up to your choice only. Okay, so these are the things is there. Finally presently we got, this is the solution. This is the solution, but this is simplification is not done up to now. Here we have to take we are using Boolean postulates and theorems, but somewhat problem is that some more simplification is there, but we cannot identifying by using this process. So for that reason now I am changing this process with the help of Karnoff map. Now I am going with Karnoff map procedure. Now I am going with the Karnoff map procedure for getting accurate output and with a very simple process. Now this process I think I have almost taken 15 minutes. 15 minutes time I have taken to compute this, even though I didn't get the answer. So for that reason I am going to the next method, Karnoff map method. With this Karnoff map method I will do the simplification. So that is the very accurate one and that will give a perfect output, right? So now coming to that K-map, Karnoff map method, that is an accurate method. That accurate method will give the accurate output and it is very simple process. It will take just 3 to 5 minutes. It's not take 3 minutes also. Just within 2 minutes we can compute that one, right? Now we will see that Karnoff map method. Now we will see that Karnoff map method.